This lesson is section 10.1. We are starting circles, so we're going to talk about lines and segments that intersect circles. So first, some circle basics. A circle is the set of all points equidistant or equally distant from a given point, which we call the center. So if in this picture we had a dot to represent the center, whatever point they put there is the center, and that's also how we name the circle. We draw a little circle with a dot in it and then put the letter of the center. So this is circle C. A radius is a line segment with endpoints at the center and then on the circle. So if I still had that same center C and I connect it to the edge of the circle, that is now a radius. A chord is a segment where both endpoints are on the circle. So for example, if I had that same point A as before, but then I connected it to somewhere else on the edge of the circle, that would be a chord. A diameter is actually a type of chord, but it passes through the center. So if we had our point center here, C, and I went from one edge all the way through the circle to the other edge, passing through C, that is a diameter. We also have a secant, which is a line ray or segment that intersects the circle in exactly two places. So the difference between a secant and a chord is a secant has a portion of it outside the circle, whereas a chord stops on the circle. So if I went through like this, and as long as I touch the circle twice, I could call that a secant. A tangent is a line that only touches the circle once. So it can't go inside at all, but it's going to go along the edge, and that's a bad. Let's try that again. Oh, that's awful. We're not great at this today, guys. Whatever this turns out to be, it's going to have to be. Ooh, let's pretend it only hit right there. So that would be my tangent line. And bad news is we have to do it again. So we're just going to draw an arrow. Point A is the point of tangency because that is the point at which the tangent intersects the circle. So let's start out. Just tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent. So segment AC, if I look at my picture, AC starts at the center, goes to the edge. That is a radius. Segment AB goes from one side of the circle to the other and passes through the center, so that's a diameter. It's more specific than a chord because it went through the center. Ray DE, so starting here, going here, that touched the circle just once at point B, so that is a tangent. And line AE, because it has endpoints on the circle, but it contains parts outside the circle, we would call that a secant. So you go ahead and try this one. Pause when you're ready to see the answer, hit play. All right, so segment PR was a diameter, line MN was a tangent, line PQ was a secant, and segment QO was a radius. So in our next example, we're going to give an example of each segment or line using the circle. Or in this case, center is a point. So the center of the circle would be point K. A radius, I could either say KJ, KI, or KL because all of them start at the center and go there. So we don't have to give all of them, so let's just say KJ. And that's a segment. A chord, so we know a chord has endpoints on the circle. And while JI is in fact a chord, it does go through the center, so I would probably call that a diameter instead. So we could say segment HI or segment JL. So let's go HI. So we just said the diameter, we looked at one of those, from one end to the other through the center, JI. A secant is a line that contains parts both on the edge, has parts outside the circle but goes through the circle twice. So we could either say line IG or line JL, so let's say JL. Tangent touches the circle exactly once. So the only one that I see on the outside that touches the circle once is GJ. And then the point of tangency where that touches the circle is at point J. So that's my point of tangency. So go ahead, try the next one, pause. When you're ready to see the answer, hit play. All right, so the center was point A. There were two radii, so either a segment AD or segment AB. Chord, I have segment CH. A diameter, I have segment BD or DB. The secant, I said line CH. We also probably could have said line BD. The tangent, line GE. You could have called it GF or FE. That's fine. And the point of tangency was point F. So speaking of tangent lines, let's look a little deeper into things that are tangent. So a tangent line, like we said, intersects a circle at exactly one point, and we call that point the point of tangency. But here's the new part. A line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So we call it tangent as long as there's a right angle at the point of tangency with the radius. So I want to determine, is segment ST tangent to circle P? And I can determine that by figuring out, is there a right angle here? And since this is contained in a triangle, to figure out if I have a right triangle, I would use the Pythagorean theorem. So opposite what is supposed to be my right angle would be my hypotenuse, and I'm going to use my other two sides, 12 and 35. And we don't know what's happening here. So we can put a question mark, put something there. So when I do this, 12 squared plus 35 squared, I get 1369. And 37 squared, I get 1369. So yes, they are equal, which means yes, it is tangent because we have found that angle STP is a right angle. All right, so ST is perpendicular to TP. So you go ahead and try this one, pause. When you're ready to see the answer, hit play. All right, this one was tricky because they didn't tell us this part. They only told us the part outside was 2. But since this is a radius and this is a radius, the radius has to be the same because it's equidistant. So those are both 3, making the new hypotenuse 5. And then, yes, we do in fact see that it is a right angle because it's a right triangle. So yes, it is tangent. In this one, they're telling us point J is the point of tangency, which means I know for a fact that there is a right angle here, making x the hypotenuse, that's my C. 6.4 is one side, and the other side is actually 3.5 plus 3.5, which is 7. So we're going to do 7 squared plus 6.4 squared equals x squared. So when I add 7 squared and 6.4 squared, I get 89.96. And when I take the square root, we get about 9.5. So you try the next one, pause. When you're ready to see the answer, hit play. All right, so on this one, x is again our hypotenuse, so we're using 7 and 19 as the legs, and we're going to get the square root of 410, which comes out to be about 20.2. A few more things about tangent lines. If two segments from the same external point are tangent to a circle, then they're congruent. I call this the ice cream cone problem, idea, theorem, whatever you want to call it. Because if you imagine you have a cone with an ice cream scoop on top, you want the two sides of that cone to be the same length, otherwise your ice cream is going to fall out, right, if it's uneven. So the two sides of our cone have to be the same. And if I have multiple cones, we just know that each of those two sides have to be the same, the two sides that make up each of the cones on our single scoop of ice cream. So if a polygon is circumscribed around a circle, then all sides are tangent. So our first example here, we're going to find AB if both segments AB and CB are tangent to circle D. So looking at our ice cream cone, we want these two to be the same. So we would set them equal. Subtract 5x, add 19, and we get x is 14. And we want to find AB. So we're going to do 5 times 14 plus 23. And we get AB equals 93. So you're going to go ahead and try the next one. Pause. When you're ready to see the answer, hit play. All right, so we set our 3x plus 4 equal to 28, and we get x equals 8. All right, the last kind of problem we're going to look at, we're going to find the perimeter of this whole quadrilateral. So the big values we're going to use to find individual pieces. The two individual pieces are not the same as each other. Remember, these are a bunch of ice cream cones. So I know these two pieces are the same. So if this is 23, this is also 23. And if together these two pieces were 37.5, if I take away the 23, I get 14.5 for this piece, which now matches this one. So this 37.5 is actually done. We're not going to use it anymore. We know the individual pieces. We don't need to know what it added up to. I now have this one here and this one here have to be the same. So I already know this one here is 27.1. So that's also 27.1. And then because these two had to add up to 52.5, if I subtract that, I get 25.4. Which means this is also 25.4. And I'm going to imagine that this 52.5 is gone. So now I'm going to add up everything, and I notice there's 2 of every number. So I'm going to do 2 times, and I'm going to add up 1 of each number now. 14.5 plus 27.1 plus 25.4 plus 23. So we're going to do 2 times all of this. So it's really 2 times 90, and we get a perimeter of 180. So you're going to try the very last one. Pause. When you're ready to see the answer, hit play. All right, so here is our answer. I got a perimeter of 71. I knew both of these were 2.5. I knew both of these were 17. If this is 21, take it away, I get 4 for these. If this is 29, take away 17, I get 12 for these. So 2 times the sum of all of those numbers gave me 71. And that is the basics of circles and tangents.